Hello students, this is Srikar speaking. So the problem that we have today is use trigonometric identities, algebraic identities and inverse trigonometric functions as necessary to solve this equation in the given interval 0 to 2 pi. Now they're asking you to round the answer to 4 decimal places. So you do all the steps and for the final answer you round to 4 decimal places. So the given equation is this. So in order to solve something like this, what we would like to have is, do we know some equation which has secant x and tan x involved in it, which is some kind of identity? Yes, we do have. That is like we have this secant squared x minus tan squared x is 1. This is one of the identities. So what we would happen is, from this equation I can write secant squared x as 1 plus tan squared x. So now why did I do that? Because you'll see in a couple of minutes. So this I'll substitute secant square this in place of secant squared x. So 2 times 1 plus tan squared x plus 4 gives me 7 tan x. So the whole purpose of doing that is converting entire equation into single known tan x terms. So now what do? I just distribute this. 2 plus 2 tan squared x plus 4 gives me 7 tan x. So now 2 and 4 are like terms. So 2 tan squared x plus 6 gives me 7 tan x. I would like to have every term on left hand side of the equation. So what I would do is subtract 7 tan x from both the sides. After I do that, what I will be left with is 2 tan squared x minus 7 tan x plus 6 equal to 0. Now here this looks like, let us name it equation number 2. This will look like some kind of quadratic equation in tan x. So if you feel this is a bit difficult to handle with, let us consider tan x equal to a, which implies tan squared x will become a squared. So wherever you have tan x, you replace with a, and wherever you have tan squared x, you replace with b, a squared. So number 2 equation becomes 2a squared minus 7a plus 6 equal to 0. This is quadratic equation in a, for which we already know the roots. It is minus of a negative 7 plus or minus negative 7 whole squared minus 4 times 2 times 6. This is equal to over 2 times 2. Negative of negative is 7 plus or minus negative 7 whole squared is a 49 minus 4 twos is 8. 8 times 6 is 48 over 4. 49 minus 48 will be 1. So this is left over with this. Square root of 1 will be 1, which is 7 plus or minus 1 over 4. Now we have two situations. A is 7 plus 1 over 4. A is 7 minus 1 over 4. Here 7 plus 1 is 8 over 4, which is equal to 2. Here a equal to 6 over 4, which can be further simplified as 3 over 2. But if we look carefully on the top, we have substituted something like tan x in place of a. So what we need to do now is replace back a as tan x, which means tan x equal to 2 and tan x equal to 3 over 2. Now here we use the inverse trigonometric functions and do the following thing. X will be tan inverse of 2 and x will be tan inverse of 3 over 2. So these are two different situations. We feel that these are two different answers. Now what happens is when you read the question carefully, they are asking you in the interval 0 to 2 pi, which means in 0 to 2 pi, 0 pi over 2, this will be pi, and this will be 3 pi over 2, and this will be 2 pi. In all the four quadrants, quadrant 1, 2, 3, and 4, in 0 to 2 pi, tan x is positive in two different quadrants, quadrant 1 and quadrant 3. So which means for every solution in quadrant 1, you'll have to add a pi to get the third quadrant solution. So for example, x equal to tan inverse 2, x equal to tan inverse 2. This is one equation. X equal to tan inverse 3 over 2 is another equation. Another solution, I mean. So now, one more solution you get is pi plus tan inverse 2 and pi plus tan inverse 3 over 2. So these four are the solutions of the given thing. Since it is in 2 pi, 0 to 2 pi, we have four solutions. Why? Because here tan is positive and here also tan is positive. So you'll get two solutions here and two solutions here. So total number 4. Solution 1, 2, 3, and 4. That's it. Thank you so much.